Hi everyone, so my name is Zach Vines, and today we're going to look at how to calculate a value given a probability in Microsoft Excel. So at this point, one quick note is that this is going to be for normal distributions only, so if there's another function for a different type of distribution, that's not what we're talking about right now. This is just dealing with that bell-shaped curve, the normal distribution for right now. So what we've done often up to this point in statistics is that we were given some number and we were looking for a probability tied to that number. Like what was the percent chance of this value occurring in this probability distribution? And we have a lot of videos dealing with binom.dist, Poisson.dist, we have norm.dist. We're given values and we're finding probabilities tied to those values. And you can see that with all of those, the type of function we would use in Excel was a .dist, whether it was binom or Poisson or norm.dist. It was always a distribution.dist based function if we had a number and we're looking for the probability tied to that number. So I'm making a very specific point of that because what we're talking about now is we are given a probability, a percent that is tied to a number, and I want to find out what that number is. So for the purpose of this video, we're going to designate the number that we're looking for as k for right now. And it makes sense that if normally we're looking for a number and we're finding a probability, it's .dist, whereas if we're given a probability and we're looking for a number, we're going to use .inv. Just think about it as the inverse of what we're normally doing, of what you're probably used to doing up to this point in statistics. So the .inv function gives you a number tied to a probability. So this is the formula right here. This is the Excel function that pops up when you type in equals norm.inv. These are the fields that you have to fill in. So oftentimes in the problem, you're going to be given the mean and the standard deviation. Like you kind of have to have that information or at least the raw data to compute that. Oftentimes, if you're just in your introductory stats courses, they're probably just going to give you this is the mean, this is the standard deviation, and it's going to be of the population as a whole. It's just this guy right here that's a little bit tricky to figure out. It's really the main purpose of this video is identifying what to plug in for that so that we can find the number tied to the probability. So the probability that we plug in right there is the probability that that number is tied to. But what I mean by that is that basically it's the number in question, the probability that it is sitting on. And what I mean by that is that when we have a distribution, we have a probability distribution, it goes from 0 to 100%, and oftentimes we don't know the exact number it begins on and the exact number it ends on. We just know that we have some distribution at play with that mean, with that standard deviation, that is 100%. We're considering the entire distribution to be 100%. So if we're starting at 0% and we're ending at 100%, the probability that we put in for norm.inv is really saying what percent is k sitting on in the distribution. So for instance, if I had enough information where I could back into this, and we're going to go through one example in just a moment to kind of wrap your head around exactly how we would do this, but let's say through one way or another, I found out that k is at the 25% mark in my distribution. So if we're starting at 0, we're ending at 100, I identified that k is right at that 25% mark. 0.25 is what I put in for the probability. It's all very theoretical. It might be hard to wrap your head around to start with. So let's go through one quick example. It'll probably make it a lot clearer. So let's do that right now. Okay, so for this problem, you can see that we're dealing with a test average for a class was 80, with the standard deviation of 5, and only 10% of the class did better than you. So we're wondering what your grade is, at least approximated kind of based on the statistical relationship between the information we have. And so you can see in this situation, and I understand that a grade is a part out of a whole. It is the percent that you got correct for most of the time. But just for the sake of this problem, let's kind of tie in the grades, like the test average and the standard deviation, as values you're given, and then solve the problem based off of that. So you can see that we are given values. We're given an 80 as your test grade, or not your specific test grade, but the average test grade, standard deviation of 5 points on the test, and we are given that a 10% of the class did better. So we're given a probability, and what are we looking for? A specific value tied to that probability, what your grade is, given that only 10% of the class did better than you. So one note I want to make is that sometimes you might see it sort of in layman's terms, just like a situation explained to you like that, or you may get very technical notation to say this exact same thing right here. So what that would look like is that we're saying the probability of some number x in this distribution, some grade, being greater than your grade, which is the number in question, what we're looking for, k, is 10%. So the probability that one of the grades in this distribution is better than yours was only 10% of them, okay? So remember, in order for us to solve for this, given a number and we're looking for, or we're given a probability and we're looking for a number tied to that probability, given the situation, we're going to use norm.inv instead of norm.dist. So what were the inputs for that? Well, we were looking for the probability, which we have to find the probability tied to the number we're looking for, which is the trickiest part, which is what we're going to do right here. But really, we're doing the mean and the standard deviation. Apart from that, they tell us the mean was 80. They tell us the standard deviation was 5. So just plug in 80 and 5 right there, and you'll be good to go. So that's not too bad. So really, we're just trying to find what is the probability that your k, the number in question that you're trying to solve for, where is it sitting on in the distribution? So we know that we have a distribution that begins at 0% and 100%. So again, I'm saying this 0% isn't like the percent correct. This is not representing the grade you got. This is like the distribution as per the 0 to 100%, with the entire distribution being 100%, not the grade that you got. And we're looking for the number that's tied to the specific probability that we're looking for. Well, pretty much, long story short, if I know that only 10% of the class did better than me, so meaning that if we're sitting at 100%, I go 10% back, and k is going to be sitting right here. So k is here and 100% is here, meaning that this remaining 10% is who did better than you. So what is k sitting at? It's sitting at the 90% mark, the 0.9 right there. So that's pretty much how you find the probability. You have to back into the logic, go, okay, we have a distribution starting at 0, ending at 100%. They're telling me that the only percent of the distribution that was greater than the value I'm looking for is 10% of them. So that means you're sitting at the 90% mark, so 0.9 is what you put in for your probability right there. You just crank out that calculation, 0.9, 80, 5, and it gives you about an 86.41 is what we would expect for your grade to be. So you can see this is definitely trickier when you're used to doing the .dist, where you're given a number and you're looking for a probability tied to that number. This is just the exact opposite, and the main trick is to find that probability right there. But you might see the notation like this. This should be a really good example for you to wrap your head around. So I hope that helped, and thank you so much for watching.